Hi, everyone. We're Leonid and Leonid, both co-founders at Feldera. And today we're going to show you a quick demo to drive home what we mean when we say that we can bring you real-time SQL powers to your lakehouse. Now, you might think real-time SQL is an overused phrase. There's several vendors who kind of make the same promise. But we make a very strong claim here, and it's a very differentiated claim, which is that any SQL that you should be able to run in your batch system of choice, we can run that in real time or in streaming mode. Right? So we're going to show you that with a quick demo involving a security operations use case that we love to show our users. So yeah, take it away, Leonid.
All right. So imagine that you're building a security product that continuously collects information about software deployments in your customer cloud environment, and it performs security-related analytics on this data. So for example, you might be collecting information about the source repositories, the CI/CD pipelines that compile the source code from the repos into binary artifacts that later get deployed in their Kubernetes clusters. And you also maintain a database of vulnerabilities that can be used to detect vulnerable source code inside customers' Git repositories. So one example of analytical query you may want to run on this database is a query that tracks how your vulnerabilities propagate from the source code via CI/CD pipelines into the Kubernetes clusters and report statistics about these potentially deployed vulnerabilities to the customer. You can define this analytics using SQL, and your data warehouse or lakehouse already provides everything needed to run those SQL queries in batch mode. Now, the problem with this approach is that every time you run this batch job, it is going to read and process the whole database. It can take a while, and it can cost a lot. And if you wanted to serve the most fresh results to your customers, then you will want to run these batch jobs frequently, and that will proportionally increase the cost. So with Feldera, you can eliminate this expensive batch job and instead process your SQL queries in real time as the data streams into the system. So we are going to tee off our data streams into Feldera, and whenever we have a new update coming from the customer, Feldera is going to use the exact same SQL queries that you ran into your warehouse in batch mode. It is going to recompute this query in real time and output an update into the output SQL table, usually in under a second. So let us see how this actually works. You're going to start with modeling your input data in Feldera using standard SQL create table statements. So for example, we have a table here of CI/CD pipelines, a table that describes Git commits, a table of binary artifacts, a vulnerability database, and so on. And then we are going to write our analytical queries as views built on top of these tables. So for example, we have a view here that computes the set of vulnerabilities affecting every CI/CD pipeline as a join between two previous tables. So this is standard SQL. It's exactly the same query you would be running in your database or data warehouse in batch mode, and that's exactly the point. That you don't need to learn a new language or a new dialect to program Feldera. If you know SQL, you already know how to use Feldera. Now here's something interesting. We are going to take this view we just computed, and we're going to use it over here to build a more complex view that tracks vulnerabilities inside binary artifacts. And this way, we can combine simple queries to build really complex, deeply nested analytical pipeline.
And you might think like this is actually, it might increase your latency or might increase complexity, but in fact, we strongly encourage you to do this, right? Like stacking views on top of each other, building more complex views out of simpler parts. Feldera really can process all of this incrementally and in real time, and you shouldn't worry about the performance cost of doing so. Yeah.
That's correct. This might be considered an anti-pattern in some other systems, but for Feldera, this is normal and encouraged to build this kind of modular pipelines out of deeply nested views. All right, so we are going to define a few more nested views here, and then our final view is going to track statistics about the number and severity of vulnerabilities in your Kubernetes cluster. So it will store the total count of vulnerabilities and the most severe vulnerability level per each Kubernetes cluster. So now that we wrote these queries, we are ready to build our streaming pipeline. So the pipeline consists of the program we just wrote. Here it is. So the input tables are shown on the left, and the output views computed based on those tables are on the right. So to run the pipeline, we need to connect streaming data sources to every table. In this case, we're going to stream data from a set of Kafka topics. I still have to add one of them to the pipeline. And likewise, we're going to stream our output views into different Kafka topics. And you can imagine that this output topic can, for example, be connected to a table inside your Snowflake workload. All right, so we can now run the pipeline. We can see how this pipeline is ingesting and processing data in real time. We can look at the contents of our output view, and we can see how, as new data arrives into the system, we are able to update the output view in real time. Now, let's show how this works in slow motion. So as this pipeline is running, I'm going to use our REST API in order to feed a small change to this pipeline. So in this case, I'm going to change the severity level of one of existing vulnerabilities to a very high level of 100. And we're going to see how this will affect our output view. So I make this change, and we instantly see that all the Kubernetes clusters that have source code with this vulnerability deployed, their vulnerability level instantly grew to 100. And the nice thing about this is that normally it could take an hour to run this whole batch job from scratch. But because Feldera does incremental computation, which means that the work you're going to do to process a small change like this is proportional to the size of the change and not the entire state of your database. This is why we are able to update those views in real time.
So you might also, if you're paying close attention, you might also see that in some cases the values are changing, right? Like clusters that had the most severe vulnerability at 100 are also going back to the previous value of 4. And this actually shows a particular capability of Feldera in that we can actually process inserts, updates, and deletes to input tables. So what our workload generator here is doing is that it's also simulating updates where software artifacts and particular pipelines are getting removed from the system. And that's actually being reflected in the vulnerabilities also reverting when those artifacts are no longer running on those clusters. Yeah.
That's right. So let's summarize. In this demo, we combined Feldera with your existing data warehouse to deliver the best of the two worlds. We use Feldera to evaluate your queries in real time at a fraction of the cost of batch processing and get results in usually under a second. But at the same time, all of your raw data is still stored in your data warehouse and is available for historical processing and any kind of ad hoc analytics in the future. Thank you.
Thank you.